Welcome to Just Mathematics. We are going to be taking on more complex problems in indices in this session. Remember, in our last session, we were able to solve two problems in indices. But this time around, we are going to take on two more complex problems in indices. But don't forget, I told you that the same principle works for all of them. If you are able to, no matter how complex the, the problem is, number one rule is that you are able to understand the laws and apply them step by step. Okay, so let's take the first example. Before you go on, you might want to go through your notes to see how far we have gone and to be able to refresh your memory concerning the laws of indices. There are 7 of them, and we are going to be needing all of them. Let's take the first example. The first example says evaluate without using tables eight raised to power 1 all over 3 times 7 raised to power 2 all over 3 divided by 14 raised to power 2 all over 3. That's the question. And we don't want to use tables. We don't want to use calculators. We want to solve them using the laws of indices. Okay? So, it will be very good to take this one step at a time. Let's take it one step at a time. So we can break down 8 further. We can break down 8 further. Remember, we can't use the first law here because both of them are not even when after we have broken it further, there's no how we can break 7 further. So both of them cannot be the same base. So we can't for the numerator we can't use the law of indices for this, the first law. So we can't use that law for this too. So we go through another route. But we can break down this, and we can break down 14 too. Okay, so let's break down 8. Let's break down. Eight raised to power 1 all over 3. So if we break it down, we can break down that 8 to 2 raised to power 3. 8 is 2 raised to power 3. 2 raised to power 3 is 8. Raised to power 1 all over 3. Don't forget, still have our 1 all over 3 there. Do you get that? So we have, if you multiply it, you have 2 raised to power 3 times 1 all over 3. 3 here cancels 3 here, leaving you with 2 raised to power 1. Okay, let's keep that at that. Let's keep that there. Or before we even go further, don't let me go ahead of myself. So I want to cancel that step. I don't want to go ahead of my step now, of myself now. Let me leave it at that. And we have that to be 2 raised to power 3 all over 3. Let's keep it at that, because we are going to be needing that. So also we can break down 14. We can break down 14, 2 raised to power 14 raised to power 2 all over 3. We can break it down to 2 times 7 raised to power 2 all over 3. This becomes 2 raised to power 2 all over 3 times 7 raised to power 2 all over 3. So that's what that becomes. Now we want to bring in all what we have been able to get. We bring it, we have 2 raised to power 3 all over 3 here, times we have 7 raised to power 2 all over 3 divided by 2 raised to power 2 all over 3 times 7 raised to power 2 all over 3. Now, there is something I want to do. There is a step I want us to take. That is why I did not complete this step. This step here, that's why I left it at this. Because there is a step I want us to go through. Now, it's the same thing. I could as well put 2 raised to power 1 there, which I'm even going to put. But there is a step I just want us to go through. That's why I left it that way. And so, gathering like terms. Gather like terms. When you gather like terms, you have this and this are like terms. 2 raised to, both of them have the same base. You have the same base here. You have the same base here. So they are like terms. But how do we bring up this? If you are going to bring up this, what happens? Don't forget, if you go back to our previous notes, you'll find out that there is something that somersaults a number. Take for instance, when you have a raised to power minus x is the same thing as that minus somersaults it. That's 1 all over a raised to power x. This minus will have somersaulted it. So likewise, if you want to turn this one back and bring it up, it's still going to say you're still going to introduce back that minus. You understand it? So it's the same thing we want to do here. We want to bring this one up. So we are going to introduce the minus. So you have 2, 3 over 2 over 3 times 2 what? Minus 2 all over 3. Because we brought it from down, brought it up. Do you understand? Then we continue. Times, we do the same thing here. 7 2 all over 3 times 7 raised to power minus 2 all over 3. Do you understand that step? And we can apply the law of indices. You can see that this and this are the same base. So you can gather them here. You have 2 raised to power 3 all over 3 plus minus 2 all over 3, right? Times 7 raised to power 2 all over 3 plus minus 2 all over 3. We get that step. Look at it very well. There is no magic there. It's simply taking it one by one and following the principles. Study it very well. So we go to the next step. Open up the bracket or do this. That step that I said we should escape the other time. We can just do it now. So we have 2 raised to power 3 all over 3 is 1. Open that bracket. When plus and minus comes together, what did I say? What sign will dominate? Did you say minus? You are right. Minus 2 all over 3 times, do the same thing here, 7 2 all over 3. When you open the bracket sign, minus dominates, minus 2 all over 3. Good. We want to work this. We want to work 1 minus 2 all over 3. 3 is the denominator. This one is the same thing as 1 all over 1. That is the same thing as 1 all over 1. 3 divided by 1 is 3 times 1 is 3. Minus 3 divided by 3 is 1 times 2 is 2. So you have 3 minus 2 is 1 all over 3. So you come back here, you have 2 whole number 1 all over 3. 2 raised to power 1 all over 3. 2 raised to power 1 over 3. My apologies. Then times 7 raised to power 2 all over 3 minus 2 all over 3 is 0. Is 0. Therefore, and there is a law that states that a raised to power 0 is, can somebody tell me what it is? You can go through your notes. 1. You're correct. Therefore, 7 raised to power 0 will be 1. So we have 2 raised to power 1 all over 3 times 1. Did you get it so far? So what will your answer be? Your answer, therefore, is 2 1 all over 3. It is 2 raised to power 1 all over 3 times 1 is 2 raised to power 1 all over 3. Or, you can tell me what that can be. 2 raised to power 1 all over 3 will be what? The cube roots of 2. Good. At this juncture, I would like to say that if you have any questions, you can reach me on 080 33 94 5202. 080 33945202. You can send your questions to that WhatsApp line and I will reply you in case you have any question. All right, having done that, let's go to our next. You can go to our next question, that is question 1. Don't forget we are taking more complex problems in indices, and that is the first we have taken. All right, so let's solve this. Let's take another one. Okay, without using tables 2 here, without using tables, evaluate okay 1024 raised to power 1/5 times 0.02 raised to power -1 times 125 raised to power -1/3. Without using tables, evaluate 1024 raised to power 1/5 times 0.02 raised to power -1 times 125 raised to power -1/3. Okay. You want to study the question? Whenever you see any mathematical question, don't be afraid. All you need to do is to have proper knowledge of the principles. Have proper knowledge of the principles attached to that topic, and you just take it one after the other. All right. So we have a proper knowledge of this. We know that from the law, that says a raised to power 1/x is what? The x roots of a. The x roots of a. Therefore, we know that 1024 raised to power 1/5 is the same thing as the fifth root of 1024. And by that, I mean, what can you multiply 5 times to give you 1024? You want to go through that to see what you can multiply 5 times to give you 1024. What did you get? The answer is 4. The answer is 4. 4 times 4 times 4 times 4 times 4 will give you 1024. Okay? So you take the second one. The second is 0.02 raised to power -1. Take it one after the other. We have two issues here. The first one is that we need to interpret this. We need to interpret 0.02 before we can even come to that. So let us interpret 0.02. 0.02 as a decimal is the same thing as, remember when you did decimals, your point will represent what? 1. Good. Every other figure after it is 0, 0. Leaving us with what? 2 all over 100. Fine. That is what you learned few years back. So having dealt and interpreted 0.02 to be that, then we can bring it back to say 2 all over 100 raised to power minus 1. Do you want to tell me what this is? What does this negative sign up here represent? It somersaults this, leaving you with what? 100 over 2 raised to power 1. If you got that, good, you're on the right track. That means you have been following all that we've been saying. You leave that at that. And 100 all over 2 raised to power 1 is the same thing as 100 all over 2. 3 raised to power 1 is 3. 100 raised to power 1 is 100. Anything raised to power 1 is that same number. Okay. So we go to the third one. Can you see that when you handle mathematical problems step by step, you will not miss it. So the next step is to take 125 raised to power minus 1 all over 3. Can you tell me again what this minus represents? It means that you are going to somersault this. So somersault it, you have what? 1 all over 125 raised to power 1 all over 3. Don't forget the raised to power 1 all over 3 up here. I think we've done something like that in the past, in our past problem solving. So this is the same thing as saying 1 all over the cube root of 125. And the cube root of 125 is 5. So it's the same thing as saying 1 all over 5. Very simple. So we are going to combine everything now. Combine every step. So don't forget we got 4 in the first step times we got 100 all over 2 in the next step. Don't forget this 4 can be also 4 over 1, so it won't confuse you. Then times the last step we got 1 all over 5. Okay, we can cut out now. 2 here, 1. 2 here, 2. 5 here, 1. 5 here, 20. Multiply how? 2 times 20 times 1 is what? 40. All over 1 times 1 times 1 is 1. So our answer is 40. Do you understand how to solve these things now? These problems now? You can look through them again, step by step. Look through the laws of indices. Follow them accordingly, and you will have no problem solving problems in indices. Thank you for coming along with me and giving me the privilege to teach you. Don't forget to hit the like button and to subscribe to this YouTube channel. Thank you.